So question asked over here is the resistance of the conductivity cell containing 0.01 molar KCl solution at 298 Kelvin is 1500 ohm. What is the cell constant of the conductivity of 0.001 molar KCl solution at 298 Kelvin? What is the cell constant if the conductivity of this same solution is this? Now, what is the conductivity cell? Now, where it is used? Like conductivity cell, circuit diagram setup I will show this way. Okay, simple setup is there. Let's say these are the electrodes, these are the electrodes, these are the plates. Okay, these are the plates, electrodes. And here we connect a current measuring device to measure the flow of current, and in this case electrolyte is there. Now in this case something which is going to remain constant, is this distance between the plates and the area of cross section of the plates, or this area of the plates is going to remain the same. You may change the electrolyte through this. You can change the electrolyte. Its concentration could be varied. Everything could be varied. But what is going to remain is length and the area of cross section of the electrodes are going to remain constant. So this is what is the cell constant, is ratio of the length and the area of cross section is a cell constant. Now when we do a setup, resistance is directly proportional to length and inversely proportional to area of cross section. So resistance is equal to rho and this by A. Now what you are told to find is L by A. L by A is a cell constant, right? L by A is a cell constant. So what is this cell constant will be is equal to? L by A will be is equal to resistance into, this is what resistivity or constant of resistance. Now, is there a resistivity given? No. The opposite of the resistivity is conductivity. So, how I can write this? L by A is equal to R, rho is equal to 1 by conductivity. Resistance opposite of the resistivity is conductivity. It could be written inverse of this. So, sorry, what I have done? L by A is R by rho. Okay, so R by rho means what? Rho is 1 by K, inverse of the conductivity. Therefore, L by A is equal to resistance into conductivity. So what is resistance? 1500 ohm multiplied by conductivity is what? 0.146 into 10 raised to minus 3 Siemens per centimeter, right? So this will be what? Answer comes to 0.219 L by A, 0.219. Unit will be what? Per centimeter. Unit will be per centimeter, because this Siemens and ohm, they are opposite, or Siemens could be also written as a per ohm, right? If you want to do the units illustration, then unit of this is ohm and conductivity is Siemens per centimeter, means it could be also written, Siemens could be also written inverse of ohm per centimeter. This and this get cancels, and what remains is per centimeter. And you can also take an example like L by A is what? L is centimeter. Units of L by A, L is centimeter, and this is what? Centimeter square. This and this will get cancelled. So centimeter inverse will be the unit, right? Next question is the resistance of a 0.01 molar NaCl solution at 25 degrees is 200 ohm. The cell constant of the conductivity cell uses unity. Calculate the molar conductivity of the solution. See, molar conductivity is what? Molar conductivity is conductivity upon concentration, right? This 1000 is conversion factor. Usually concentrations are in what? Moles per liter, that is moles per liter. So we need to convert this to a moles per ml. When we multiply this 1000, this concentration is as good as writing moles per ml. I'll tell you what is the reason for writing it to be moles per ml. So here conductivity is given to be what? 5.0 into 10 raised to minus 3 ohm inverse and centimeter inverse, right? Multiplied by concentration. How much is the concentration? 0.01. Now what is this 0.01? Capital M. 0.01 capital M means moles per liter. Means if I write this 0.01, it is moles per liter. Liter is not matching with centimeter. No? I want something which is matching with centimeter. So I multiply this 1000, which is already there in a formula. So this becomes, instead of moles per liter, this becomes moles per ml. Here main thing is about units. So this answer comes to 5.0 into 10 raised to minus 1. So answer comes to what were the things? Yeah, I did not consider this. This is 10 raised to 3 and this will be 5 into 10 raised to 2, right? So if you want to write this, you will write this 5 into 10 raised to minus 3, this will be 10 raised to plus 3 and this will be 10 raised to minus 2. So this and this will get cancelled and this will come on the top. So 5 into 10 raised to 2. So molar conductivity, I am getting it to be 5 into 10 raised to 2. Now what will be the units? Let's check the units. Lambda m, the units of this was ohm inverse per centimeter, and units of this 0.01 moles per liter. I converted to moles per ml by considering this conversion factor. So I am writing this moles per ml. So what is this? Ohm inverse, centimeter inverse, mole, and this is centimeter. ml means what? Centimeter cube raised to minus 1. So ohm inverse, centimeter inverse, mole, centimeter cube. So this will be ohm inverse, centimeter square, mole inverse. So Siemens centimeter square per mole will be the unit of this. So this is unit of this will be Siemens centimeter square per mole. So units are also very important. This is very nice question, very interesting question. The two graphs are given, in graphs two plots are given, A and B. So predict the nature of the electrolyte A and B, that is what is asked. See, for a strong electrolyte, it is very easy to calculate a molar conductance. So this is the axis where it is molar conductance, and this is the axis telling you about the concentration. As we go on the right side, concentration is very high. When it is here, it is 0, means concentration is less. So when the concentration is 0, means what? You will get a maximum amount of the conductivity, limiting molar conductance, maximum value of the molar conductance, right? That is what we say. Now, limiting molar conductance is the conductance at an infinite dilution. Infinite dilution means what? Not adding an infinite amount of the water, but it is the conductivity where value of the conductivity remains same after dilution. What happens with dilution? Okay, to explain this concept, what I'll do is I'll explain you in this manner. Conductivity of the electrolyte depends on two factors. One is depends on, I'll write, depends on two factors. One is mobility of ions, and second is number of ions. So what happens is that for strong electrolyte with dilution. With dilution, what happens? The space between the ions increases. Let's say A plus and a B minus. With dilution, they are going to go apart. So mobility increases for a strong electrolyte. Okay, number of ions for a strong electrolyte is going to remain same, whatever may be the dilation, only the mobility is increasing. So here plot is very uniform. With dilution, the molar conductivity goes on increasing, right? And at an infinite dilution, what will happen is that you will get a maximum value of the molar conductance. This doesn't mean that you have added an infinite amount of the water. At certain concentration, tending to zero concentration, this value is lambda naught m, means maximum value of the molar conductance. This is for a strong electrolyte. And for a weak electrolyte, what happens? Weak electrolyte, what happens? With dilution, dissociation increases. With dilution, dissociation increases. Therefore, number of ions increases and also mobility increases. Mobility of ions increases. Mobility of ions increases. Means here both the factor mobility as well as number of ions increases for the weak electrolyte, because at lower concentration the weak electrolyte is not completely dissociated. At higher concentration the dissociation for the weak electrolyte is not maximum, very less. As we go on, put on more and more water into that, dissociation increases. So both the parameters are increasing. So what will happen as the dilution is going on? This will be the curve, like it is going to increase, and they are never going to meet. So that's why for a weak electrolyte, to find a limiting molar conductance, we use a Kohlrausch law of independent migration of the ion. So this is what is A over here. A is a strong electrolyte. Understand? Answer for the first one. It is a strong electrolyte. And what is B? Is weak electrolyte. Isn't it? What happens when extrapolation of the lambda m to the concentration approaching to 0 for the both A and B is done? What do we get is a limit for a strong electrolyte. Answer for the second one. Answer for the second one. This one, for strong electrolyte. When extrapolation is done, it intercepts at a y-axis. For strong electrolyte, we get the value of limiting molar conductance. So lambda naught m. And for weak electrolyte, they never meet. For weak electrolyte, what happens is that so we cannot find lambda m for this weak electrolyte. It will run parallel, right, to y-axis. For weak electrolyte, we cannot find lambda naught m graphically. For this we require a Kohlrausch law. So over here, calculate the degree of dissociation of acetic acid. Like, what is the meaning of this? Alpha is equal to lambda m by lambda naught m. Lambda m is a molar conductance and lambda naught m is a limiting molar conductance. Lambda m is a molar conductance and lambda naught m is limiting molar conductance, or this is also called as conductance at infinite dilution. Lambda m by lambda naught m. Alpha value is always less than 1. Always remember, alpha value is never more than 1. Maximum value of alpha is 1. So always remember that lambda m is lower value and lambda naught m is bigger value. So never make a confusion with this formula. So we need to find a lambda naught m for the acetic acid. So lambda m is given, right? So lambda naught m of CH3COOH is what? Lambda naught of H plus lambda naught of lambda naught m of CH3COO minus. How much is that given? 349.6 plus 40.9, right? So this comes to 390.5. Yeah, no, this comes to 390.5. So therefore alpha is equal to what? 39.505, that is 390.5. So this answer comes to 0.1 alpha. So this is what a degree of dissociation. It doesn't have any unit. Alpha is unitless quantity. Because units of both these are same, they will get cancelled out. Thank you.